Here's exactly how the MCAT's going to test you on Western Blots. Make sure you can answer questions about these and not just explain how they work. If you like these explanations or the illustrations, you can sign up for my MCAT community or schedule a consultation call about that via the link in my bio. Here's a blot for a protein that we will call protein A. First, digest and understand the setup of the blot. Our first column is showing the protein under native conditions, which is how the protein normally is in the cell. We are also looking at how molecule A and molecule B affects the protein, and under that native column, neither of those are present, as indicated by the minus minus. We have a band up here at 100 kilodaltons, which means under native conditions, protein A weighs about 100 kilodaltons. The next column is showing what the protein looks like after being treated with SDS. SDS coats the molecule in negative charges, which disrupt all intermolecular forces. This is going to disrupt all levels of protein folding except primary structure, so only peptide bonds and other covalent bonds are maintained. If the protein has multiple subunits, the subunits will be separated unless they're held together via disulfide bonds. We see that we still have one band at 100 kilodaltons. This indicates that if the protein has multiple subunits, they are held together via disulfide bonds. Next, we do a reducing SDS to confirm if there are disulfide bonds present. We see that there are two bands, which does indicate that there are disulfide bonds present, and the reducing SDS broke those up to separate this protein into multiple subunits. Now, the part that I love testing on that you want to make sure you never forget is to use the weights to then figure out exactly how many subunits there are. Even though we only ended up with two bands, we know that these molecules have to add up to 100 kilodaltons since that's the weight of the protein under native conditions. But we see that these two subunits only weigh 50 and 25, which don't add up to 100. What this means is that this protein consists of one subunit that weighs 50, but then two subunits that weigh 25. So then this protein is a heterotrimer. For the last two columns, we're looking at what effect does molecule A or molecule B have on the amount of this protein. When we add molecule A, the band gets a lot thicker, so something about molecule A increases the amount of protein A. When we add molecule B, the amount of protein A is decreasing, so something about molecule B is decreasing the amount of protein A.